Hi everybody. Today I'm talking to NBS technical author Gordon Gray, who's been the sort of main lead author behind the early stage specifications. And I've known Gordon for over 10 years when you were in practice, and then since then joining NBS as a technical author. But you were part of our advisory panel, Gordon. Who was it you worked for at the time?
I think I worked for Rumjum at the time. I've been in a few practices in my extensive career, lots of different things, probably in practice for about 30 years really. The advisory panel was the first time I got enthusiastic really about specification and more to the point about specification through the timeline, and it's taken some time to get there. It looks like we're getting there now. I suppose I'm one of the few architects or the many architects in the technical authoring team, because I suppose, as you say, it includes structural, mechanical, electrical engineers and landscape architects at the moment. Do you need to know what the team does?
Right. Yeah. I guess you cover all the disciplines. And in terms of your role, in particular, which areas, which sections do you sort of maintain, Gordon?
Yeah, as an architect, you have to be fairly flexible, but I have had for some time now the cladding and roofing sections. So anything to do with building fabric, really. I don't tend to get into the interiors or the floors. So I'm an externals man.
Yeah, and that's in both content sets, isn't it? So you author the content in the CAWS format and the Uniclass.
And small works.
Yeah, and when you worked in practice, what was the practice large enough that you just concentrated on specification, or did you get involved in the drawings, client
Well,
relationship?
I think in the whole scheme of things, I've been involved in everything right way from, getting a client brief, meeting the clients, getting a design concept prepared, right through to approvals on to technical specifications, contract drawings, working on site, monitoring things on site. So covered most things, I would say. Never been particularly good at any of them, but I've covered most of them.
Yeah, and I'm just going to share my screen, so going to keep this quite relaxed. But what we're talking about today is the early stage specification library, which is a project I've been working on for a number of years, but really accelerating in the last 6 or 7 months. It's nearly going to get released. And I just want to show these two slides off and ask you questions about them, Gordon. But
Yeah.
I think this shows traditionally where NBS lives, putting together that sort of tender spec or technical design spec. And what we're going to talk about today is the early stage specification that allows specification to start sort of almost when you receive the brief from the client. But in your own words, Gordon, what are we trying to achieve here with this new content set?
Exactly what you've said. I think one of the things that always irritated me was that people regard the specification really just as the technical specification for tender, for construction, for getting the job built, forgetting that really a lot of your specifications developed pretty much as soon as you start working. As soon as you get the brief, you're beginning to take decisions, you're beginning to record things. And in the early stage, you're talking to planners, to building control, to clients, to funders, to different organisations to communicate what the proposals are way before you get to the technical specification. So what we should be doing now is really thinking about how we allow people to record all that information in one document rather than the many documents that I used to have to write, all with the same content on them, all in different orders, all confusing, all sometimes with omissions and errors. So it'd be nice to think of all of that early stage stuff being in one stream, one thread, for want of a better word.
So literally, did you have things on whiteboards, post-it notes, Word documents, Excel, and gathered all of that sort of
Yeah, I
stuff
mean,
down?
you would do your staged reports, your stage C report as it was then, to get design approvals. That'd be a nice, 10 page, 20-page booklet of images and specification. And we got to building one, same thing, images and specification. We get to planning, images and specification, all the same submissions done at different times and usually in different documents.
Yeah, and I guess the reason you couldn't use like full MBS is because you didn't know all of the material choices at that stage. You were working at a sort of elemental level.
Yeah, I mean, early days, you're really recording information to do with the site, then to do with the building, and then to do, for me, the focus of this has to be the element, because it's covering all of the fabric of the building. It's the walls, the floors, the roofs, things that we've been able to describe bits of up until now, but this will be the first time we can describe the performance of the whole construction, which I think is very significant.
And I think you've done a nice illustration for us just on this slide sequence here, where you maybe it's quite a simple building. I know maybe most projects people work on are more complex than this, but you've got a floor plan here, and you're sort of breaking it down into the spaces and then the elements that define those spaces. Can you say a bit more about that please?
Yeah, I suppose early stage design is all about activities, and then accommodating activities in spaces of the right size, with the right environmental conditions, the right outlook, the right amount of light, all that sort of thing. But those spaces have to be defined by elements. That's really what an element is fundamentally designed to do. And in the early stages, that element may simply just be a line on a drawing. It's just a line saying I'm a wall. In due course, it'll become a wall with some information attached to it, the U value, the fire performance, and then in due course, we'll attach systems to it, because we're really thinking about Uniclass particularly here. And Uniclass is clever because it allows us to build relationships between products and systems, and now between systems and elements. And I think that's a big move forward.
Yeah, and I was saying in terms of the color coding here, I imagine if I was standing outside the building and looking at this back wall, it might look the same in terms of its sort of the material on the outer leaf, but you've got it color coded in terms of different wall elements. Can you say a bit about why there's a different color for the back of house to the kitchen or what have you?
It's interesting. The external wall of a building can look like it's the same all the way up, but it's affected. The way it's built up is affected by what it's enclosing. So if a wall's around about a plant room, for the sake of argument, it's maybe a different wall on the outside compared to a wall that's around an office or around a bedroom, because the performance of the wall has got to reflect the overall performance of what's happening inside, or impact, or actually define the performance of whatever's happening in the space. So it may well be that the outside's timber clad or copper clad or whatever, but the insulation, the U value, the acoustic performance, the internal finishes will probably all be subtly different. But I think they're all parts or types of the same element is the approach we've got to take there.
So you said, like, looking at this, we have a sort of, I can't remember exactly the naming convention here, but like EW must be external walls, and then 001, and then you've got a 010. So I imagine they're fundamentally different elements, and then there's sort of variations in performance.
Variations are type. Yeah. I think that interestingly, we've this is a Uniclass element, so it will have a Uniclass code. The Uniclass coding can only be limited. It can't accommodate the number of variations you can get on an element. It just can't be done. So we've tended to expect that people will adopt the typical way of calling things wall types, or roof types, or floor types. Yeah. So we've used that as an illustration here. We're not saying there's only one way to do it, but I think many architects will be accustomed to building wall types in this sort of way.
And just like we're showing walls in this illustration, there'd be similar principles for the floors and for the roofs as well.
And for openings, yes.
Yeah, and of course the doors and the windows and hatches and things as well. Yeah, and then I think, yeah, we've talked about this a little bit, but you could have completely different set of systems that are put together to give exactly the same minimum performance requirements.
Yeah, one of the advantages of having an element at the early stages with a U value and a fire performance and whatever, you may be gathering all that information before you've really decided what the building's made of. And really what we're illustrating here is that each of those different constructions, one's masonry, one's timber frame, one's metal stud, with insulation in different places, effectively all can achieve the same fire performance, the same acoustic performance, the same security performance, but they can change. The element information's got to, I think, remain constant through the timeline, so that you've got this constant requirement that you can compare your substitutions against, you can compare costs against, you can change your mind as you go along, subject to always having the high level performance or design requirements set in the early stages. That also lets you, when you get to the end of the line, check and see if you've been successful, and when you verify the job at the end of the day, did we achieve what we set out to achieve? And the answer should be yes.
Yeah, yeah. And then I think, yeah, this is something we've got the core NBS content that we're going to look at in a moment, but we've also been partnering with the Building Cost Information Service. I think it's still quite a part of the Royal Institute of Chartered Surveyors, but we've been working with them to give indicative, so not to the nearest pound and pence or not to the nearest decimal place on embodied carbon, but an idea of if you're going for this sort of build-up, relatively speaking, it's 20% cheaper or it's 20% worse for the environment. Is that early stage where you have that discussion with cost consultants and clients and sort of tighten up that sort of budgeting?
Yeah, I think that sort of budget, it will depend on the scale of the job and the practice that's involved. But generally, at very early stages, when you're thinking about the whole complex, the whole building, the whole project, you'll have an overall budget that will allow you to set the tone at the early stages. So you will have decided if it's going to be masonry fairly early on. You will have decided if it's going to be a concrete structure rather than a steel structure fairly early on. But if you chose to change it at any time, then you've got the comparison to be made as you go through the process, basically.
Yeah, and I guess that the worst thing, and one of the worst things as an architect, is you put a concept design in front of a client, and then the cost consultant on the other side of the table says, "Look, that's 50% over budget." You want to sort of keep that design within the sort of parameters of the project.
Yeah.
Yeah, and I guess early stage, it's still possible to change direction and make different decisions. The longer a project goes on, it makes it increasingly harder to change decisions, I guess.
I think, well, you can always change your mind. I mean, that's part of life. You can either change it because you've come up with a better answer or a more economic answer, but there has to be some fundamental system whereby you set out your targets to begin with, you set out your design and performance requirements to begin with, you agree them with the client, and they become fundamental to the contract, basically. As you go along, things may need to change, but at that point, they should only really change with a design approval from the team and from the client, but that will happen.
Yeah, yeah. And then what we've got here on the screen is a little extracts from the clauses that we'll show it in the software itself in a second. But I guess the idea is that you just start adding little bits of information as you start to understand it. So what we're seeing on screen here.
The first thing you're going to talk about, once you've got the job, is with the client to decide what the brief's going to be. And for the brief, generally, we would have had a large document which would have spoken in high level principles and ambitions, but very soon would have got into detail of how the activities, the spaces are to work, and consequently how the elements are to work, what the construction is. So at the early days, interestingly, the use of language would be different here, because this is not a technical specification. This is a communication between client and architect that can be shared with the public or with people who are less technically minded. So besides thinking about early stage topics like the client brief, planning, building control, there's probably different language styles you're using at this point as well, because it'll begin to become more and more technical as you go through the timeline.
So if we just, I think this is a progression of slides showing how the specification would develop, and you'd have a number of these elements in the specification. But this next slide here, things do start to get a bit more technical, and in particular, this clause item 3.1 on performance requirements. Yeah. Can you say a little bit more about what's happening here, please, Gordon?
Yeah, we're thinking about an external wall, and we're thinking about what, regardless of what it's made of, we need to think about what its performance will be. Because in the early stages, you'll run a SAP, a thermal analysis, you'll run a carbon analysis at early stages. you run a cost analysis at early stages, and they'll all build into the specification. And at this point, we've concluded the U value is going to have to be whatever it is. There's a fire performance requirement, there's a durability requirement, and there's a requirement for water penetration, or to manage water penetration. These are illustrations, and there are many different performance requirements that will apply to all the different elemental types. So this is really just us setting the tone, if you like, setting the beginnings of a structure to the content.
Yeah, and you're very clearly saying, look, we are going to have like this U value as defined
and to a particular standard. Yeah,
this durability as a following standard. And just interestingly, in the top here, because I imagine there will be early stage conversations with the client, with the planning authority, and you may make notes about which like individual products that have been decided on, as well as just sort of memoirs type things.
Yeah, it'd be nice to think the design process is absolutely linear, but it never is. It's always intermittent and iterative, I would think. And at this point, we're simply saying to the client, we're thinking that it's going to be metal tile cladding, drained back ventilated rain screen, in words that they'll understand, with some dimensions getting in there, because your dimensions are getting set fairly early on, so everything fits basically. This is really setting the beginnings of the specification for the client, which will grow into the specification we talked to the planners about, which will go even more and in more detail to the discussion you have with the building control, and then in due course will become part and parcel of the technical specification.
And I noticed that item 4 here, there's maybe a little section where you can put maybe notes for other consultants, like a sustainability consultant or maybe a cost consultant, in terms of what your assumptions, advisory items have been.
Yeah, we thought a while ago that we needed to get content in here that wasn't necessarily going to be part of the technical specification, but needed to be there to share with other members of the design team, so they understood the context in which the decisions had been taken. And the advisory item there was thinking about if you have used an energy analysis tool, or you looked at BCIS, you need to understand at that point what you've looked at, what the analytical tool has told you, and record it here so that other people, structural engineers, mechanical engineers, can see where the decision process is going. But the advisory bit, we're calling it advisory because it's not part of the technical specification, it's supporting the technical specification.
Yeah. I guess it's all about that sort of collaboration, isn't it, across the team. And then as we come into this here, this is, I guess, the introduction, the gateway into your traditional NBS technical specification, where you're specifying the systems, the products, the materials.
Yeah, I think one of the significant things of an element in particular, elements in particular, is that they effectively bridge the early stage of the project and the technical stage of the project, because they're gathering all the early stage content, they're building up the rules, if you like, around which the wall construction is going to develop, and they therefore set the tone for the different systems that are going to be accommodated as part of that element. So here we're saying constituent systems. So if it's a wall, there's any number of different systems could be brought together to make up a wall. In this case, we're choosing it's rain screen. So we've got 3 established systems already drawn, already authored in the content: drained back ventilated rain screen outside, a masonry wall inner leaf, and then into a wall lining system. So there could be 3 systems in the element, there could be 1 system in the element to achieve the overall performance requirements of the element. There could be more. It's where we do the bridge, but it's also the place where the requirements at the top half of that clause will stay, but through the timeline, the constituent systems can be changed for cost, or for materials, or for aesthetic appearance. So I'm quite keen to emphasize that the performance requirements and design requirements that sit with the early stage elements, and ultimately entities and complexes, which will be part of Uniclass, run constantly and will only change with careful design approval. But the systems can come and go, and you can develop the content, the technical content, interestingly, I think the intention is to show just a connection here, not to repeat what's in the system content here. You can find it here and then go and look in the system, look at what the system content holds, the technical content.
Yeah, I think that the way we want from the software point of view is, like, you'll notice that like people that are familiar with Chorus watching the conversation here, these are sort of grey chips, which means they're just sort of placeholders. So at the early stage, this could be a 3 or 4 page document covering the elements, and all you have to say is it's a masonry wall leaf system. But then as the project develops, then you'd add that to the technical spec. It turns into a green chip, and you can actually click the hyperlink, but it prints out as a bookmark, so you're not trying to mash everything together. But I think this demonstrates what you were saying earlier, Gordon, where you've got a product that's linked to a system, and then you've got a system that's linked to the element, and you can see that all sort of flow down like Russian doll after Russian doll getting opened up.
Yeah, I think that's the thing that's special about Uniclass, because it's hierarchical, and you can have products that are made into systems that are made into elements are made into entities, effectively, and that relationship is quite significant in understanding how to communicate the information for one together with the others, so that you understand how they all come together.
Yeah. And I think not shown on this slide is, through the timeline, this could go even further, where you go from elements to one of the systems to one of the products, which here's an open specification, to ultimately what was the manufacturer product that was installed and went in the building, and that manufacturer submit proposals could change to Gordon's cladding tiles or what have you.
Yeah, they're very expensive.
The best cladding tiles in the country. And yeah, we talked a lot about architecture in the main building fabric here, but it covers services and structure, external works as well, doesn't it? We just have the slightly different terminology.
Yeah, an elements class is an element stroke function, and that was decided many years ago because there was a recognition that walls, floors, the fabric is fundamental to architects and actually to M&E engineers in terms of energy performance. But in terms of they were largely planar things. They were enclosing space, and there needed to be a distinction between what the planes did and what the M&E systems did. So they're in our content they're called functions, although it's the same thing. It's a collection of M&E systems. But I think we're expecting that elements can be used in a particular way by architects, a very important way by architects, and an equally important way by service engineers. But other disciplines and other industries may use them in slightly different ways, and that's fine. I think that's part of the ability for us to offer flexibility to different customer groups, basically.
Yeah, and as a lead designer using NBS Chorus, you could invite the other disciplines in and say, look, to this structural engineer, you write a bit about the foundations and this superstructure. Say to the mechanical engineer, say a bit about the heating systems.
Yeah, elements shouldn't be discipline specific. They're always, well, not always, but they're often going to be collaborations between the structural engineer,
yeah,
architect, service engineer. Yeah, so it's a good way to encourage breaking down of silos, I think.
Yeah, and just to sort of finish off on, we're going through sort of final testing at the moment. On the screen here is actually the common arrangement of work section content, which has similar principles, but you don't have the hyperlinks going through the document. But like here's NBS Chorus, we can see that the first external wall element, the curtain wall. The second one's, I think, the one that we had in the demonstration, the sort of the rain screen cladding on the outside coming through with masonry and then wall tiles, etc. And you might not have that sort of really nice granularity of the Uniclass content, but we do have the CAWS version as well. And I guess it's familiar to all NBS users that you get the template, you fill it in to make it project specific, you cross out what you do on in the document, and you've got sort of guidance here on the right hand side.
Yeah. It's interesting that I'd always felt that Uniclass was the only thing we'd see early stage content in, because it's designed to do that. But we have, in response to customer requests, really offered an equivalent service, if you like, or equivalent functionality in CAWS. It'll be interesting to see how that develops.
Yeah, and I get the principles are here where you've got that fixed performance, captured a bit of the brief here at the top. I've parked away clause items that maybe aren't relevant on that project, and then ultimately sort of reducing the technical specification and the constituent, in this case work sections. I'd just like to demonstrate the BCIS content as well, because that's a really exciting collaboration. But if I go into this element here, I haven't filled in any of the content, but just going down a little bit, you see here we're taking this direct feed from the BCIS website. So we've got like sort of 15 costed items for roof coverings, 14 costed item for the eaves and the verge treatment, and when you click there, that jumps across and gives a table of sort of comparators. So the total cost difference between a plastic coated galvanized profile sheet roof compared to a zinc clad roof is significantly different over a sort of 50-year period. And you can see the difference in terms of embodied carbon there as well. And
as I say, I think a lot of this will be useful right through the timeline from beginning, especially at the early stages when you're thinking about the whole project. But yeah, it's looking quite impressive.
I'm quite fascinated just looking at it, seeing that lead's 3 times worse in terms of embodied carbon there than copper, and it's aluminium there. But it's quite nice to see. We're having a new column that will be shortly introduced, which is life cycle expectancy as well. So in terms of things like embodied carbon calculations, if it's only going to last for 10 years and you've got to replace it every 10 years, then maybe a higher embodied carbon that lasts 5 times as long is actually better. But it's really exciting to get this BCIS content in as well. But I think we've covered the main points that I was hoping to ask you about. Gordon, just maybe try to sort of summarize 2 or 3 of the benefits right at the end here, but I don't know if you want to sort of finish off by doing a bit of a summary around what we talked about, Gordon.
I think from my perspective, early stage is fundamental. So we've got all the content in one content stream rather than lots of different documents. From my perspective, elements is the next thing we need to do, because it's going, at the moment, we're really systems and products. The technical solution is the main focus of what we offer. To move into elements, we're beginning to move into early stage, which I think is fundamental. The fact that elements can hold information through the timeline, which can then be used to verify or check or accept substitution, and then to verify the final job, I think is a really strong offering. I think we hopefully will, in the not too distant future, get into spaces and activities, because that's the things that you need to think about the early stages. But apart from that, I think that it's probably something I've been waiting quite a long time to see.
That's good to hear. And I think that's well summarized as well. It's like early on, fix those performance requirements, develop the technical spec based on the performance, and then that gives you something to verify that that sort of end solution has met the initial brief, I guess, isn't it?
Mm-hmm.
But yeah, thanks for your time today, Gordon. And it's great to get you in front of camera as well. I know I do a lot of webinar, but you're one of the sort of unseen heroes at NBS behind the scenes looking after the content.
You can just
chat with you.
Just fuzz the picture out, it'll be fine.
Yeah, thanks. And if anybody watching is interested in getting hold of the early stage content, please drop us an email or speak to your account manager, give us a ring, sort of normal ways. But thanks for your time today, Gordon.
Take care. See you later.